Okay, so what I'm going to do here is I am working through page 227. There's two examples given and I'm going to look at 15.4 first. So we're told 25 centimeters cubed of 0.045 molar iodine solution, previously standardized, was titrated against sodium thiosulfate. The average titration figure was 27.45 centimeters cubed. We are asked to calculate the concentration of sodium thiosulfate in grams per litre and moles per litre of crystalline Na2S2O3 5H2O. The reaction between iodine and thiosulfate is this. Okay, so this is our balanced equation. I2 plus 2S2O3 2 minus goes to S4O6 2 minus plus 2I minus. Now, I'm just going to draw your attention to a couple of things. I obviously sent and uploaded a video about working out the ratio between potassium permanganate and sodium thiosulfate. We don't need to do that here because I am told in the question that my iodine has been previously standardized and it is the iodine that is directly titrated against the sodium thiosulfate. So for this equation, I only have one equation and it's directly iodine to sodium thiosulfate. I will work through an example in the next video where we actually start with potassium permanganate and then we react the liberated iodine with here. But for this question, we are given the concentration of iodine. So because of that, we can use this equation directly. What I always do is I write underneath what I know. So I'm told I have 25 centimeters cubed of 0.045 molar. That goes under my iodine. My average titration figure, 27.45 centimeters cubed. I am going to start, as always, with my molarity. So what does that mean? It means that 0.045 moles is in 1,000 centimeters cubed. I don't have 1,000 centimeters cubed in this question. I only have 25. So I multiply by what I know. 0.045 by 25 divided by 1,000 gives me 1.125 by 10 to the minus 3. That is my number of moles of iodine, but in the question, I'm asked my number of moles of sodium thiosulfate. So I have to now set up my ratio as we always do with my iodine. If I look for every 1 iodines here, I have 2 sodium thiosulfates. So my ratio here is 1:2. That means if I have 1.125 by 10 to the minus 3 moles of iodine, I have 2.25 by 10 to the minus 3 of sodium thiosulfate. That 2.25 by 10 to the minus 3 is what I have in 27.45 centimeters cubed. And if I look, I'm asked for my concentration in moles per litre. So that's going to give me 2.25 by 10 to the minus 3 multiplied by what I know, 1,000, divided by 27.45 gives me a number of moles of 0.082. Now, for the second part of the question, then I'm asked for my mass in grams. So I use my number of moles equals mass in grams divided by my relative molecular mass. My number of moles I found from part A, and my relative molecular mass I'm going to use from up here. Now, it is in crystalline Na2S2O3 5H2O. So you have to include all of that in your relative molecular mass. So that means I have 23 by 2 plus 32 by 2 plus 5 by 18. Okay, remember hydrogen is 1 by 2, which is 2, plus oxygen, which is 16. That's 2 and 16 gives 18. That gives me a relative molecular mass of 248. And my mass in grams then is my number of moles, 0.082, multiplied by my relative molecular mass, 248. And that gives me a mass in grams of 20.336 grams per litre.